Okay, here is 1.4, complex numbers, day 2. We are going to be working with division of complex numbers. And because the fact that I is equal to the square root of 1, when I is in the denominator, you will need to rationalize the denominator. And when we are rationalizing the denominator, remember that I times I is I squared, which equals negative 1. Here's an example that we will look at. Let me get a pen here. And if we have 5 over I, if we multiply both the top and the bottom by I, that will give us 5I over I squared. And I squared is negative 1. So we'll have 5I over negative 1, which is then going to be negative 5I. And looking at a problem like the second example, we have an expression here. And if you remember when we had to do the expressions before with the radicals, we had to use what was called the conjugate, which means you were using the same exact values, but you were changing the sign to be the opposite sign and writing that expression. And it was using the understanding of the difference of two squares. So we had 4 plus 3i, and that is the conjugate of 4 minus 3i. And we are going to do that on top and bottom. When we do the FOIL process, you would get 4 times 4, which is 16, 4 times 3i, which is plus 12i, negative 3i times 4, which is negative 12i, and negative 3i times positive 3i is negative 9i squared. In the numerator, we would get 25 times 4. Actually, I'm going to leave it separate for now because there's a possibility that we might be able to simplify here. So I'm going to leave it separate. Now, when we look at multiplying and foiling that denominator, we will always end up with two values here that are exact opposites of each other to cancel each other out. Like here we have 12i and negative 12i, which cancel each other out. And we also have this I squared right here, and I squared is equal to negative 1, which means, let me grab my red pen again, we will get 25 times 4 plus 3i over the 16 minus 9 times negative 1. So we'll have 25 times 4 plus 3i over, let's see here, now 16 minus 9 times negative 1 is going to be 16 plus 9, which is 25. And look at that, 25 cancels out with the 25, and we are left with 4 plus 3i. Same thing with this problem here. We're going to want to multiply by the conjugate, which is going to be 3 minus 4i, both top and bottom. And if you keep in mind, just like on the problem up here, the two middle terms that canceled out came from doing 4 times the, during the FOIL process, it became from the outer and the inner part. So really, the 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 16 came from the F part of FOIL. This positive 12i came from the O part. The negative 12i came from the I part of FOIL, and the minus 9i squared came from the L. So really we can skip the O and the I and just do the first, the 4 times 4, and the last, the negative 3i times negative 3i, positive 3i. So keeping that in mind, I would do 3 times 3 for my F part, and I would get 9. And then I'm skipping the outer and the inner, and I'm going to do the last, and I get 4i times negative 4i, which is negative 16i squared. In the numerator, these are not conjugates of each other, so I absolutely have to go through the entire FOIL process. So 5 times 3 is 15. 5 times negative 4i would be negative 20i. Negative I times 3 is negative 3i. And negative I times negative 4i is positive 4i squared. And now I need to simplify this. I've got this I squared right there, which is negative 1. So I'm going to have 15. First of all, I'm going to simplify these like terms there to get negative 23i. And then that I squared is negative 1. So plus 4 times negative 1. And then 9 minus 16i squared, that I squared is also negative 1. So I'm going to get 9 minus 16 times negative 1. Okay, continue simplifying this. My plus 4 times negative 1 is really just minus 4. And 15 minus 4 is 11. And then minus the 23i. The bottom part, this negative 16 times negative 1 is positive 16, and 9 plus 16 is 25. And I can't simplify that any further, and therefore that is my answer. Looking at some other types of complex expressions, I've got this example here where I have the square root of negative 9/4. With the fact that I have the square root of a fraction here, I want to split this up and have the square root of negative 9 over the square root of 4. And anytime I have a square root of a negative number, no matter what, I always want to convert it to a complex number. So I'm going to rewrite the square root of negative 9. Now remember, the square root of 9 is 3. So the square root of negative 9 is 3i. And at the bottom, I have the square root of 4, which is 2. So I would get 3i over 2, or 3 halves I. Looking at the next example, I've got the FOIL process, but before I do this, I want to convert my square root of negative numbers into complex values with I. So I'm going to get the square root of 3 minus the square root of negative 4 is going to be 2i. And then I have the square root of 6 minus the square root of negative 8. I have to think about, okay, the square root of 8 is typically going to be broken down to be 2 times 4, and 4 is 2 times 2. And the fact that I take pairs of numbers to remove out of the square root, that would come out as a 2. This 2 that's left by itself would stay under the radical. And the fact that it was negative 8, it's going to be 2i on the outside. So 2i times the square root of 2. And now I'm ready to go through the FOIL process. So I have the square root of 3 times the square root of 6, which is the square root of 18. Then I have the square root of 3 times negative 2i square root of 2. Well, I'm not going to change the negative 2i, but the square root of 3 times the square root of 2 is the square root of 6. Then I have negative 2i times the square root of 6. And I have negative 2i times negative 2i times the square root of 2. So that's going to be, because I have negative times negative, let me fix that. There we go. I'm going to have positive. So plus 4, because 2 times 2 is 4. I times I is I squared. And then I have the square root of 2. Looking at my terms here, I've got like terms here. So that is going to be negative 4i times the square root of 6. The square root of 18 can be simplified. 18 is 9 times 2, and if I'm thinking about the square root, the square root of 9 is 3. Okay, or if you break that down to 3 times 3, obviously you'll notice that. So I've got 3 times the square root of 2 minus 4i times the square root of 6 plus, oh, actually, I'm gonna, that's going not going to be plus, but the I here is a negative 1, so that's 4 times negative 1, which is negative 4. So that's going to be minus 4 times the square root of 2. Now I look at this and I still have like terms. I have 3 square root 2 minus 4 square root 2, which is negative 1 square root of 2, minus 4i times the square root of 6. And that would be my final answer. If you don't want to put the 1 there, you could just have negative square root of 2. That would be fine. And finally, we have one more problem here where I just have some radicals that are being multiplied. But before I multiply these, I still need to convert them to complex values, including I. So the square root of negative 7 is I times the square root of 7. The square root of negative 49, because the square root of 49 is 7, with the negative there, that would be 7i. And the denominator, 28, is 4 times 7, and the square root of 4 is 2, so 2 times the square root of 7. In the numerator, I could multiply this through, and I get 7 times I squared times the square root of 7 over 2 times the square root of 7. Since I squared is negative 1, that's 7 times negative 1, which is negative 7 times the square root of 7 over 2 times the square root of 7. And now I could look to cancel any common factors, and the square root of 7 gets canceled. So I get negative 7 halves for my answer. And that's it.